Lens flare is the light scattered in lens systems through generally unwanted image formation mechanisms, such as internal reflection and scattering from material inhomogeneities in the lens. These mechanisms differ from the intended image formation mechanism that depends on refraction of the image rays. Flare manifests itself in two ways, as visible artifacts, and as a haze across the image. The haze makes the image look washed out by reducing contrast and color saturation. Visible artifacts, usually in the shape of the lens iris, are formed when light follows a pathway through the lens that contains one or more reflections from the lens surfaces. Flare is particularly caused by a very bright light sources either in the image which produces visible artifacts or shining into the lens but not in the image which produces a haze. Most commonly, this occurs when shooting into the sun, and is reduced by using a lens hood or other shade. For good optical systems and most images, flare is a secondary effect that is widely distributed across the image and thus not visible, though it reduces contrast. Lenses with large numbers of elements such as zooms tend to exhibit greater lens flare, as they contain multiple surfaces at which unwanted internal scattering occurs. Manifestation: the spatial distribution of the lens flare typically manifests as several starbursts, rings, or circles in a row across the image or view. Lens flare patterns typically spread widely across the scene and change location with the camera's movement relative to light sources, tracking with the light position and fading as the camera points away from the bright light until it causes no flare at all. The specific spatial distribution of the flare depends on the shape of the aperture of the image formation elements. For example, if the lens has a six-bladed aperture, the flare may have a hexagonal pattern. Such internal scattering is also present in the human eye, and manifests in an unwanted veiling glare most obvious when viewing very bright lights or highly reflective surfaces. In some situations, eyelashes can also create flare-like irregularities, although these are technically diffraction artifacts. When a bright light source is shining on the lens but not in its field of view, lens flare appears as a haze that washes out the image and reduces contrast. This can be avoided by shading the lens. In a studio, a gobo or set of barn doors can be attached to the lighting to keep it from shining on the camera. Modern lenses use lens coatings to reduce the amount of reflection and minimize flare. When using an anamorphic lens, as is common in analog cinematography, lens flare can manifest itself as a horizontal lines. This is most commonly seen in car headlights in a dark scene, and may be desired as part of the film look. Deliberate use. A lens flare is often deliberately used to invoke a sense of drama. A lens flare is also useful when added to an artificial or modified image composition because it adds a sense of realism, implying that the image is an unedited original photograph of a real-life scene. For both of these reasons, artificial lens flare is a common effect in various graphics editing programs, although its use can be a point of contention among professional graphic designers. Lens flare was one of the first special effects developed for computer graphics because it can be imitated using relatively simple means. Basic flare-like effects, for instance in computer and video games, can be obtained using static or animated starburst, ring, and disk textures that are moved according to the position of the light source. More sophisticated rendering techniques have been developed based on ray tracing or photon mapping. Lens flare was typically avoided by Hollywood cinematographers, but when filming Easy Rider, Harrison Arnold was forced to modify a camera car for his Arriflex, which resulted in numerous lens flares as he shot motorcycle footage against southwestern U.S. landscapes. Costume designer Rita Riggs purposefully would sometimes dress Bea Arthur in Maud in a red that would flare to make a statement, to match Maud's personality as a red flag. Director J.J. Abrams added numerous lens flares to the 2009 film Star Trek by aiming powerful off-camera light sources at the lens. He explained, "I wanted a visual system that felt unique. I know there are certain shots where even I watch and think, oh that's ridiculous, that was too many. But I loved the idea that the future was so bright it couldn't be contained in the frame." Many complained of the frequent use. Abrams admitted it was overdone, in some places. David Boyd, the director of photography of the sci-fi Firefly series, desired this style so much, that he sent back cutting-edge lenses that reduced lens flare in exchange for cheaper ones. Other forms of photographic flare. Filter flare equals, the use of photographic filters can cause flare, particularly ghosts of bright lights. This can be eliminated by not using a filter, and reduced by using higher quality filters or narrower aperture. Diffraction artifact in digital cameras equals, one form of flare is specific to digital cameras. With the sun shining on an unprotected lens, a group of small rainbows appears. This artifact is formed by internal diffraction on the image sensor, which acts like a diffraction grating. Unlike true lens flare, this artifact is not visible in the eyepiece of a digital SLR camera, making it more difficult to avoid. Gallery. See also, bokeh, a source of circles around out-of-focus bright points, also due in part to the internals of the lens. Diffraction spike, a type of lens flare seen in some telescopes, anti-reflective coating, used to reduce lens flare and produces the red and green colors common in lens flare. References